HSRP interface tracking is a very, very powerful feature. It gives us the ability to monitor the status of an uplink. And if for some reason this uplink right here fails, meaning the interface goes from up to down, so the status changes on that interface, we can decrement our priority to a value that is lower than the standby device, and therefore the standby device takes over as the active forwarder. However, what if the failure happens up here? Right up there. Would a failure up here change the status of this interface on R2? Would it change the status of this interface? Would that interface go from up to down? No, it wouldn't. Therefore, interface tracking only helps us out if that failure is that directly connected uplink. So what can we do about failures like we see here? Well, this is where HSRP and object tracking comes into play. With object tracking, we have the ability to track an object. Now, what is an object? Well, an object can be many different things. For example, the object can be a directly connected interface. So by specifying a tracking object as an interface, we would simply be monitoring the status of a locally connected interface. So that is very similar to HSRP interface tracking that's built into the protocol. But you can also do it outside of the protocol with tracking objects. But if you want to track something further away from you, you can do so. For example, with IP SLA, IP Service Level Agreements. You could set up, for example, a ping and ping from the local router that HSRP gateway, the active forwarder, ping some IP address out there. And as long as the ping is successful, then you remain the active forwarder. But if the ping fails, you decrement your priority to a value less than the standby device, and then the standby device becomes the active forwarder. So the ping here in this case is what we're tracking. We are tracking the success of that ping. If it fails, then we can lower our priority. We could also have a list of objects that we might be tracking, or a route. If the route is in the routing table, then our priority is a certain value. If all of a sudden the route's not in the table, let's decrement our priority so we no longer try to be the active forwarder to reach that destination. Let the other router forward traffic because we no longer know about that particular destination network. So there's a lot of different items that you can track. So in this example, we could keep it relatively simple by setting up a service level agreement, an IP SLA instance, which is simply just going to ping in our case. What are we going to ping? We could ping from this router interface simply to this router interface. If the ping is successful, it means we have connectivity. Therefore, the tracking object is up, and therefore, we remain the active forwarder. But if for some reason we have a failure like we see here, then what will occur is the tracking object goes down because the ping fails. And since the tracking object is now down, it means we decrement our priority to a value that puts us lower than the standby router. So now we have a priority of 90, which is lower than the standby router, which means the standby router is now what? It's now the active forwarder. So traffic will now be forwarded this way instead of getting stuck here and getting dropped.